Hello everyone, I am Tigran and today I'll explain the function calls, parameters and ML relevance in COMP3122 Assignment 1. So let's start from the section 1, data loading functions. I used pdread CSV with the file path parameter. This loads our dataset into a data frame. In ML, data loading is the foundation. We need structured data to train models. Next, values converts the data frame to a NumPy array. No parameters needed. This is essential for ML because NumPy arrays are faster and most ML libraries expect them as input. So for section 2, manual statistical calculations. For manual mean, I used sum, ages and divided by line ages. The parameter is the ages array. This shows the mathematical foundation. In ML, we use the mean for normalization and understanding data distribution. For median, I sorted the data and found the middle value. Parameters are sorted ages and array length. Median is robust to outliers, important for data pre-processing in ML. For manual standard deviation, I used the variance formula. Parameters are ages array and calculated mean. This measures data spread and is essential for z-score normalization in ML. In section 3, NumPy statistical functions are used np.mean ages, np.std ages, and np percentile ages, 30, and np percentile ages, 70. Parameters are the input array and percentile values. These functions are much faster than manual calculations because they are optimized. See code. In ML, they work on entire arrays at once, which is essential for large datasets. In section 4, data visualization with matplotlib, I used plt.hist ages, beans equal 10 to create a histogram. Parameters are the data and number of beans. This helps explore data distribution before modeling, which is key in ML. I used plt xline to draw vertical lines at statistical landmarks. Parameters are values, colors, and line styles. These lines help interpret model results and identify data characteristics. So for section 5, NumPy broadcasting and vectorized operations. For unit convention, I used heights in multiplied by 0.0254. Parameters are heights array and conversion factor. Broadcasting allows efficient array operations. So for BMI calculation, I used weights divided by heights in power of 2. Parameters are weights and heights arrays. This creates a derived feature that incorporates domain knowledge into our ML model. And for z-score normalization, I used ages minus npy mean ages divided by np std ages. Parameters are ages array, mean, and standard deviation. This scales features to have mean 0 and standard deviation 1, improving algorithm performance. For section 7, I use train test split to split data. Parameters are features, target, test size, and random state. This prevents overfitting and gives unbiased model evaluation. I created a model using linear regression with no parameters needed. This is our baseline model, simple but interpretable for understanding ML concepts. I trained the model using feed. Parameters are training features and targets. This is where the model learns patterns from data, the core of supervised learning, and I made predictions using predict. Parameters is test features. These tests how well our model generalizes to new data, and I evaluated using R2 score and mean squared error. Parameters are actual and predicted values. R-squared measures explain the variance, while MSE quantifies prediction errors. Section 8, model visualization. I used PLC scatter to create a scatter plot. Parameters are x-axis and y-axis. data. This visualizes the relationship between features and target. I overlaid the regression line using PLT plot. Parameters are x coordinates, y coordinates, y predictions and color. This visualizes how our model makes predictions. So I demonstrated the complete ML workflow from data loading to model evaluation. Each function serves a specific purpose in the ML pipeline. Understanding these functions and their parameters is crucial for building effective machine learning models.